Hi everyone, welcome to Data 100, and this is the first discussion walkthrough of the semester. Today I'll be covering a lot of prerequisite math, which will become important later in the semester. So first, let's talk about linear algebra fundamentals. And here we see Beyonce, Jay-Z, and the Royal Blue shopping for fruit bowls at Berkeley Bowl. And as part of the information that we're given, we know that we know the price of each of the fruits that are available. So 2 for apples, 1 for bananas, and 4 for cantaloupes. And I've labeled them so for simplicity. Now each bowl is a different combination of each of the different fruits. And the goal of part A is to define a matrix B, where multiplying B with V gives you the price of each fruit bowl. So the first thing you should consider is what is the shape of B? Now we know that the product itself has a length 4, so the number of rows should be the number of rows should be 4, and we also want the number of columns of B to be equal to the number of rows in V. So B is a 4x3 matrix, and just to be more clear on what each row and column means, so each row is a fruit bowl, and each column is the fruit price. Okay, so keeping that in mind, hopefully it's more straightforward to just fill in the matrix B now. So you can just do 2, 2, 2, 5, 8, 0, 0, 2, 3, and 0, 0, 10. Sorry about that. 1 second, we just fix this. 5 and 0 and 10. Okay, so that's your matrix B. Moving on to part D. Here, you have to define the matrix A such that evaluating ABV gives you how much each person spent on food, on the votes. So now again, let's do the same process. What should the shape of A be? So we know that the length of the matrix product is 3, so there should be 3 rows. And we also want the number of columns of A to be equal to the number of rows in B. That means the number of columns should be 4. Now here, each row is a person, and each column is a fruit bowl price. So yeah, again, keeping that in mind, it should be more straightforward to define A. So Beyonce buys 2 fruit bowl 1s, 1 fruit bowl 2s, and none of the others. Jay-Z is all 1 for each, and then blue is 10 of the cantaloupe bowls. Okay, so yeah, that's part B. And then in part C, here you are given how much each person spent, but you don't know the prices of the Berkeley Bowl, of each of the fruits. So your goal is to find the new prices because they change. And how do you do that? So let's work backwards. So what does X really mean? X is how much each person spent. But that's exactly the same thing that we evaluated over here with ABV. So essentially, ABV equals X. And in our case, it's V2. So let's do a mathematical trick and multiply AB inverse on both sides of this equation. And you'll notice that this can simplify to this really easily, and I'll explain why in just a second. Okay, so this happens because that's a very interesting property of invertible matrices, where if you multiply a matrix by its inverse, it evaluates to the identity matrix. And the identity matrix times V2 is just the V2 vector. So now you have an expression for V2, which is what we're asked. However, we assume, this is very important. So we assume that AB is invertible. We're going to explore that in part D. Okay, so in part D, we are asked, why is AB invertible? So there are two checks that you can do. The first condition is whether it's a square matrix, and it is. So that we can tick that box. Second one can be expressed in a variety of ways. Could be linearly independent, or it could have a determinant of less than of not determinant not equal to zero. And there's like multiple ways of doing the same thing. However, I'll just talk about the first method of checking whether all the columns are linearly independent. So you can do this very intuitively. Here, you see that third vector is the only vector which captures some information in the third dimension. And these two are not scalar multiples of each other. So that information itself is sufficient for us to say that our matrix is linear, or the columns of a matrix are linearly independent. Okay, so that's question one. Let's move to question two. Here, here in this question, we'll explore a lot of different concepts in linear algebra and through these different parts. So the first question is about this matrix M, and it's asking us whether it's possible to construct a zero vector using a linear combination of the column vector. So what does a linear combination really mean? So linear combination is where you can multiply the column by an arbitrary scalar and scale it, and then you can add those columns together. So let's put that into actual math. So let's let alpha 1 and alpha 2 be constants. Alpha 1 is the coefficient of the first vector. Alpha 2 is the coefficient of 0, 3, the second vector. So if you do the math, this will evaluate to 2 alpha 1 and 3 alpha 2. And the only way this becomes the zero vector is when alpha 1 is equal to 0 is equal to alpha 2. Right? And that is the trivial case, which we don't really want. We only want non-trivial scenarios. So to prove linear independence. So in our case, since the only way we can make this the zero vector is by setting the constants to 0. Our matrix is actually full column rank, and it has two linearly independent vectors. So we can say that the rank is 2, which implies that it's full column rank. All right. And let's talk about invertible matrices again. So here you have the same matrix M, and you're asked to calculate the M inverse. So let's assume that M inverse is of the form A, B, C, D, and we know the property that M times M inverse is the identity matrix. So let's write it out. 2, 0, 0, 3 times A, B, C, D. Okay. So this will give us 2A, 2B, 3C, and 3D. And we also know that this is supposed to be equal to the identity matrix, which is this. So now you have 4 equations and 4 unknowns. The unknowns are A, B, C, D, and you can just find them out. So this will give you that B equals C equals 0, and A equals 1 by 2, D equals 1 by 3. What you notice is that it's actually a very interesting property of diagonal matrices, where the inverse is just the inverse of the diagonal elements, like literally taking the reciprocal of that. Okay, so that's part B. Moving to part C. You have a matrix Q, and you're asked to find the column rank of the matrix. Now, just by looking at Q, you can tell that if you multiply the first column by 5, and the second column by 5 as well, you can get the third column. you can get the third column, right? And so this essentially means that the third column is linearly dependent on the first two columns, and you can do this for any combination of them. So at any given, for a given combination, there's only two linearly independent columns. So the rank of the matrix is 2. And is the matrix invertible? It's not square, so it's not invertible. Okay, so that's just a simple check. For part D, we have this matrix R, which is Q transpose. Now, transpose is when the first row becomes the first column, the second row becomes the second column, and so on. So our R matrix would be 1, 0, 5, 0, 1, 5. And you can clearly see that since they're not scalar multiples of each other, they are linearly independent from each other, which means the rank is 2. And you could also say that it's full column rank. Okay, so that's question 2. And let's move to calculus, the calculus portion. So here, this is all you need to know really from like multivariable calculus course. So you're trying to take partial derivatives, and this is important for functions which have multiple variables. So here you have a function which is dependent on two variables, x and y, and it's really this complicated looking expression. And let's try to break it down. So for part A, we need to find the partial derivative with respect to x. Okay. So in this case, to take the partial derivative, we actually just treat all the other variables as constants and essentially take the regular derivative with respect to that variable. So this is a simpler case where you can easily do 2x and then you treat y as a constant, so it becomes 4y. And then none of the other terms have an x in it, so those terms evaluate to 0. The second case is a little more tricky in terms of the math, but feel free to refer to a table and just for the derivative expressions. But essentially, the first term would go to 0, and the second term would just be 4x plus 6y squared minus 3 to negative 3y plus 1 over y. All right, so that's part B. And again, these are the partial derivatives. So although they're treating the other variables constant, for example, y is constant over here, you could think of the partial derivative itself as a function, and that function is still dependent on x and y as variables. Again, this might sound more complicated than it is. So for now, let's just focus on evaluating these derivatives. And so for part C, you have to find the gradient of the function. So that's literally just assembling different parts that we have calculated. So 2x plus 4y for the first derivative. And then this thing for the second derivative. And yeah, normally gradient is a column vector, but you can represent it as row vector if you have the transpose sign. And we can evaluate this function at 2, negative 1. And this will give us, the first term would be 0. And the second term would be 13. Actually, let me just use square brackets. 13 minus 3 e cubed transpose. Okay, so that's the calculus portion, and that's the end of discussion 1. If you're filling out the attendance form for this discussion using the walkthrough, use the password, which is here. So the password is formal And you can just use my name, Ragnar Nevetia, for submitting your attendance form. Okay, so hopefully this was helpful, and I'll see you next week. Hi everyone, welcome to discussion 5 for Data 100. Today we'll be talking about some probability and sampling as well as some simple linear regression. So let's get started with the first question. In this question, you're trying to sample some houses on a street, and here you're given 12 different houses with different combinations of numbers and letters. And in this case, the sampling technique that Ishani uses is she picks a letter, one of A, B, or C, at random, and then surveys every household with the same letter, with that same letter. So that directly brings me to the first question. What is the chance that two houses next door to each other are both in the sample? So for that question, I really want you to look at the street and really look at which houses share the same letter. So once you've done that, you'll realize is that that there's a pattern in the houses that they go in the ABC order. So ABC, ABC. So houses with the same letter actually do not share any boundaries. Therefore, since there's no event such that which satisfies the condition, the chance for two houses being next to each other and having the same letter is 0. So that's just the answer for part A. Okay, so let's go to the part B. So in part B, Ishani once decides to collect a simple random sample, and this time we are working with 4 houses. And in simple random sample, since you do not replace, you need to do all these different selection, all the 4 rounds of selection, one by one. So let's get started with the first round. So probability of 1A not surveyed. So in the first round, there's 11 out of 12 options for 1A to be not surveyed. And that is the first round. And after the first round, since one house is being selected, there's only 11 houses remaining. And out of them, only 10 houses satisfy this condition. And let's keep going 4 times. And once you do that, you will get 8 by 12. Now you might ask, why am I multiplying all these numbers instead of adding or subtracting? So the reason I'm doing that is because all of these things have to be true. So 1A should not be chosen in the first round, should not be chosen in the second round, and so on. And since all of them have to be true, you need to be multiplying the probabilities. So that's why the probability of 1A not being surveyed is 2 by 3. Okay, so let's talk about part C. Part C is, I guess, a little more complicated. So here, your sampling technique is a little different. So now instead of surveying every member, you are surveying 2 members in each house. So you're also given that in 1A, 4 people live, and one of the people living there is called Bob. So you want to find the probability that Bob is not chosen in Ishani's new sample. So let's try to break this down into like words, and then we can fill in the math. So first of all, you need to talk about what you're trying to find. So probability that Bob is not surveyed. And we can also write this as 1 minus probability of Bob surveyed. Okay, and now comes the tricky part. Now you want to break down how whether Bob is surveyed into different components, because now there's 2 conditions. So for Bob to be surveyed, 1A also needs to be selected in the simple random sample. So you have to consider the scenario where, given that 1A is selected, what is the probability of Bob being selected? And then you also need to account for what is the probability of 1A being selected overall. So let's put that in words. Probability of Bob surveyed, given, this is the given sign. This one is the given sign. So given 1A survey, and this is times probability that 1A is surveyed. Okay, so now let's finally put in some numbers. So again, you have the 1 minus, and then if 1A is surveyed, and since 1A only has 4 people, out of which 2 are two are going to be chosen, there is a 1/2 probability of Bob being chosen in that sample, just because there's two members to be chosen, and there's 4 people in the house. And so let's multiply that by the probability of 1A being surveyed. And what you'll see is that in part B, you found the probability of 1A not being surveyed. So 1 minus 2 by 3 is just 1 by 3. And you can do that over here. And finally, if you work out this math, then you should get 5/6. Okay, so let's go on to part D. Part T is actually, so there's no space here, but let's try to work it here. So part D is asking us that Shani wants to gift a small present to 4 houses, and she's sampling with, and this time she's sampling with replacement, so a house can be chosen multiple times. So what is the probability that all the C houses are given a gift? So the C houses possibilities are 1C, 2C, 3C, and 4C. And this time again, we are sampling with replacement, so keep that in mind. So in the first round, when she's choosing who to give a present, there are 4 options for the C houses out of 12. And again, we want to keep on multiplying because we want all 4, since we can only select 4 houses. And here we have a condition that all of them should be C houses. So if the first one is a C house, assuming this is 1C, for example, the next one, that only leaves 3 options, these 3 options for the next round of choosing. So that means that you have 3 in the numerator, there's only 3 more options. However, since you're sampling with replacement, you will be sampling 12 different houses again, and this will keep on going until you have the 1/12 option, which is the last option. Now again, this is how you can sample. This is the probability for how you can, of all the C houses being selected in this scenario. You could also write this as 4 factorial over 12 to the 4. Okay, so hopefully that was some good review for the probability exercises.